So hello everyone. Today our topic is PayMotion, but firstly we will cover. It's my tradition to ask on the question from the class during this. It was safe question, so when I have my office hours. Actually, I decided that the best day is on Thursday because actually on Monday I have free class of linear algebra. So I will totally die after this, and it's not a very nice idea to ask me about some smart stuff. On Tuesday you have 5 classes, so we have other story. And it seems that Thursday is the best day, so you have half an hour probably to have a rest, and 15. It's okay for everyone? Maybe you have some extra, I don't know, classes or something like this, no? Okay, so I won't, so you need to write me, I will go, and after this I will come. Actually, I prefer to go at home after our classes, but if you need, I will see it on Underground Robotics Lab. You know it, I hope so.
In garage?
Yeah, not in garage, but after the garage. Yes, Underground Robotics Lab. Yes, and I will be there. I have a table then. So what else? As I said before, the first row will explain who you are. I'm waiting the second row.
So,
3 questions. Your name, of course, where you're from, and your research interest in robotics. And the last question was about why you're here, why you decided to become a slave.
okay. So, my name is Igor, and I'm from Perm, and I started interesting in robotics maybe just 1 or 2 years ago. So I don't have so much experience that some guys already have, but I hope that I will find some very interesting topic for me to research in the future. In school, I really loved physics, especially mechanics and thermodynamics. So, I started to interest in robotics closer to grade, so I decided to go here. And maybe I will find some good experience.
Yeah.
I'm Stepan, I'm from Voronezh. I don't have a lot of experience in robotics. I'm in graduate school. Yeah, it's not much. That's it. I also love physics, so I thought that it's going to be an interesting experience. My research interest, I think, is autonomous cars, at least for now. So this track seems to be the most close to the autonomous cars. So
Where is Timur, if not mistaken? Yes. Okay. -2.
Okay, hello everyone, my name is Mirna, I'm from Syria. I chose robotics because for many years of my life I participated in robotic competitions, and I tried to work a few times also in manipulator and in design, and I think most of my interest now is the robot software systems, and I'd like to be a developer for them.
Hello, my name is Danila. I'm from Uzbekistan, Tashkent, remote side. I don't have any experience with robotics. Neither did I love too much physics at school. But due to Professor Gafonov, I liked it more. Some time ago I watched a video how a manipulator robot folded origami on some of them как будет выставка? Ну, короче, на выставке.
On Expo, okay.
Yeah, on Expo. And I was very inspired with what robots can achieve. So probably my research will be connected with manipulators.
My name is Anton. I'm from Tabot. It's human vision, and I don't have by now any research interest and experience in robotics. But I chose this field because I love physics at school as a kid, and actually I want to do something by my hands, not only by computer.
You will do it in my next class, I mean semester. We have mechanics and machines, and in the end you need to make in hardware the whole mechanism. And you need to calculate kinematics, dynamics, Chi, computer-aided engineering, so durability and blah blah blah. And in the end you need to assemble it in the end. If you go to underground robotics lab, near to my, let's say, table, you can see the results of the previous students.
My name is Kirill. I'm from Novosibirsk. My field of interest is control theory, especially designing control systems, observers, different stuff for tensegrity robots. I'm currently designing an observer for tensegrity robot. And I really love science, control theory, math, linear algebra. I'm not really good at physics, but I hope that I will boost my skills.
Are you living here in Novosibirsk or Akademgorодок?
In Novosibirsk.
Okay.
But maybe like if I wouldn't go to Innopolis, I would study at Akademgorодok.
It was really nice. At least we were here on 2 months ago, probably, yes. Okay. So now about quiz. By the way, I hope everybody has sheet of paper. If no, I do some. Yeah, yeah. It's 10-minute quiz. It's just to check your knowledge. Nothing more. What was the formal criterion for today? Yes, exactly. Don't forget about it. Highlight answer.
What about cheating? Like,
Cheating,
the opponent allowed to have a cheat sheet?
You don't need it there. It's goal to check your current knowledge. I told you it's only 10% of the course. Come on. If I see that you're a smart guy and you work a lot, but you have some problems, I can give you some extra score and help to, how to say, neglect this gap between A grade, for instance. I did it before. My goal not to drop you, my goal to help you to understand. But for this, we need to work. Actually, don't use phones and so on during this. Yes, because it's not very interesting.
So cheat sheets not
Not. Yes. For now, because in the future we will use it. Okay. There are 2 questions. We will finish at 25. X, Y, and x2 dots, so you need to find transformation from this to this.
Without translation.
What do you mean? No, with translation. Full transformation. You had it from the linear algebra recap.
question. I cannot see the letters.
Alright, so x,
My bad.
x, y,
Uh-huh.
x, y.
Uh-huh.
It's not a tricky. You don't need to make mirroring for something like this. Don't worry. In real life, you usually don't need to do it.
Do we need to get the exact numbers? Like, that
If you
numbers
can,
are...
it would be nice. If you write just equation, it would also okay this number. Or do you mean about
first, second task?
Second task, I
Second.
told you.
Okay, so each block is like, we can consider it as one?
Again,
Like, the units, like, can we consider it as one? Like, from the grid?
you mean the score of each task, or I didn't
No, 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 I
The
mean,
cells.
for a second task, the
grid
cells.
size.
the grid
cells,
size.
It's better to take the S1, one cell one.
Yep.
One cell on the left side. 1, 2, 3, 4, 5, 6.
Since you have that, I missed. So, what have you told about XY? Is there something about that?
X, Y, X,
Okay.
Y. Да, да, да.
5 minutes left. One minute left. Don't forget to write down your name and highlight answers. If you're ready, you can give it to me.
No, I'm just. What does it mean? Like show up the properties. What does properties mean?
Think.
The equivalent is the general equivalent, right?
I will explain each task control. Time's up.
Okay. Yes, sir. Let's start from the second task. Actually, you answer, and you need to make only one matrix. Okay, first of all, when we are talking about rotations, we should positive rotation is counterclockwise or clockwise?
Counterclockwise.
Counterclockwise, yes, it's correct. So x, y, x there, 45 degree. Everybody agrees. So we have rotation 45 degree. Okay, let's talk about pure rotation. Rotation is cosine minus sine, sine cosine. Agree?
Yeah.
Okay. Translation. We are going from old to new. So our translation is
Minus 1/6.
minus 1/6.
P1.
I mean pure translation, pure rotation. Okay, so your answer should be
Should it be -1? Or
Why not -6?
Why is it -1/6?
because in old, sorry, my bad. Yeah.
Shouldn't it be
Minus 6 and
Yeah, x should be minus 6, 1. Yes. Thanks. That's it.
Yeah, but we also see that the length of the vector has changed. Like here's 2 cells and there's
You
something
didn't
else.
specify the dimension of one on each
In
axis.
this case, you can do it, okay. But I also accept this stuff too.
Okay.
You can edit. Actually, it's only one. It's one extra transformation. You just need to increase. Yes. I mean to change. So you will do it this one, and after this, you just need one more matrix, which will how to say. Because I hope you remember that this guy, how it's called in general. Affine transformation. It's not rotation magic, but affine transformation, which helps us to make mirroring. In this case, it should be -1, and so on. In this case, you can just also change the scale like that, because these two, how to say, these two guys, they how to say, these two guys help you to increase or decrease each dimension. So in this case, you multiply on probably 1.5 or whatever. This. That's it. Yeah.
Can you please explain why we have -6 and 1?
Yeah.
Not
Because
-1.
x is there,
Yes.
y is there. I need to go from this point to this point. Do you agree?
Yeah.
So x, how can I move to this point? 1, 2, 3, 4, 5, 6. But positive direction there. So I go just -6.
Ah.
And yes, it's the reason it's tricky that I put it in the opposite direction. Okay, we spent 3 minutes with explanation. Okay, second task, the first task. Natural notation. Dimensions.
V is 2-dimensional. Like tau is also 2-dimensional.
Okay, actually in this case I expect because we thought in general we're talking about 3 dimension, but okay, if you wrote in planar, I will accept it. So 3 by 1. I mean 1 by 3 doesn't matter. Okay. And what is it? It's scalar 1 by 1.
What if I like wrote n by 1 in the tangential vector? It's okay?
Property tangent of the tau is always tangent to the curve. It's a property. Actually, always tangent to the trajectory. That's it. 1 minute. As I told you, 10 minutes is no more than enough. Any questions? Yeah.
What do we mean by properties?
Is it property of tau that is always tangent?
So just say that tau.
Yes.
Okay.
It's property.
I have a question. What if I like wrote n by 1, not 3 by 1?
I told you.
Ah.
You wrote in general. Okay.
Okay.
Why do I need to surprise me? Yes, for you this is this. you're already grown guys, and you need to understand that in real in real career, there are no exist right solution. So, in some cases, I will give you, at least I did it in linear algebra, but Ivanov told me that you are too young, and I mean, he is a lecturer, that it's not a good idea to give it in the first year. Some tasks which have completely different solutions, but it depends on your first assumptions. When you're solving a real task, you need to provide some assumptions. For instance, I don't know, I assume that you can write in the beginning. You read it, okay, I don't see that it have different, you wrote in the beginning. I assume that it doesn't matter, it was a mistake of the lecturer. You just write it in the beginning, and you solve it like this. Should I accept it? Yes, because you explain why you did it like this. It's right solution. You didn't write it, so in this case I say I accept it. But in general, okay, but it has different, scalar, and you're wrong. But if you explain that I suggested like this because this, or for instance this property, I didn't get what is property, or I think that property like this. Because in real life I cannot say that you're right and you're right. It will be both acceptable cases. As it's the same. I wrote in general way, and okay, in planar case, okay, but you need to explain that it's planar case. In three-dimensional, because it was in slides, okay, three-dimensional. Did you get it? Mainly, this way will affect you on research home task and on reports. Because in this case, you should provide your thoughts, not only numbers or something like this. Okay, again, our cheat sheet, because it might help us today, and I will just open the slides. What else? Transformation probably will not need it today, but it might help you in some cases. Second one. Why I put it there? What is it? I will explain. As for me, originally I didn't understand that for me I have two completely different entities. It's just my explanation of this stuff. You may understand it differently, Gaponov can explain it differently, and Malaretov. But we can connect linear stuff and angular stuff, and then we have something angular. In complex motion or whatever, we always have both angular and linear stuff, and they connected to each other. It also affects in dynamics, force and torque. It has all exactly the same equations, but F will be there, torque will be there. Torque equal F multiplied by rho, and the same. So, as for me, it helps me to understand physics better. Is the reason why I put it there. Why also it helps us? Yes, we have some fancy equations there. How to find accelerations. Also, probably you remember, like that v divided by v, blah blah blah. It was just bless you, like this. We have all these fancy equations, yes. But how also can we solve? If we know kinematics, x, position. How can we find velocity and accelerations?
We take the derivative?
Yes, exactly. So, in analytical way, you just take a derivative. Don't forget about it. What else? If you have some linear stuff and you know that you have angular, you can just find something and use these equations and find, for instance, omega on the whatever. So also don't forget about it. In this case, why I also like skew theory, skew symmetry. Because in this case, okay, how I need to operate with, let's say, this cross product. Yes, in this case just multiplication, and I need to minus 1, and that's it. In this case I don't need to think. In this case, how to put omega in different way. So, we have first task. It's your task. Now, I need one guy. Okay, so it will be competition. Each table need to night and solve this task. One guy, if somebody wants to go there, he will receive a gift in spite of his solution and his speed. So if you're sitting there, one of you should go to the yes. Who wants to go to the whiteboard?
Depends on the task.
You receive what again?
Depends on the task.
Task is there.
What is the gift?
Gift? It's a secret, you know. Gift would be a, how to say, surprise.
Actually, I could try to go to the board.
What again?
I could try to go to the board.
Okay. So in this case, some of you should go to him. We need to balance.
Brought some chats with me.
Yeah, of course. You can you solve it on
Yeah, sure. I'll try. I don't have to ask you.
No, I mean you're not the side.
Oh, hi.
Yeah, hi.
Okay,
Yeah,
sure.
Okay, guys, let's go. The table who solve should explain it together. So it's not an individual task, it's team task. And they will ask each of you how you solve it.
From which angle it starts?
Start again.
From which angle it starts from?
Fine, problem,
You can assume.
I hope you understood that velocity and acceleration is vectors, so you need not only a value, find a value, but also a direction.
Please show the chipset slide.
Again?
Could you please show the chipset slide again?
Do you want to take pictures?
Can I write it down? Where do you want?
It's up to you.
Task back, please.
You have 10 minutes, otherwise nobody win except him.
Did you get why there is one? Except what is it called there? Did you get it? No. Why there is zero, so there is one? I don't understand why is there one. Like I had it with one because I remember it, but when I tried to calculate it, I removed the one. So I had the one and
I got the idea.
So I will actually it can be not only one.
I can discuss it in the office hours.
It will be the question in the next class.
Why it's one?
Yes.
Oh, okay, nice. Because I was
Actually, it
confused.
can be not one, but in robotics it will be 001, but in general it can be zero.
Because I have it. No, I have it. I had it like if you look at my solution, I had it one and then removed it and put it zero because I was confused. ايه؟ لا هو بيقول لك انت فاهمه ليه؟ هي المفروض تبقى I had like I had no something to highlight with. I had like this one. Can I highlight? Okay, how should I highlight next time? Like should I like buy a marker? Okay, so like because it was so English.
Okay, I get it that it's like this.
ده دايما احنا عارفين هو دايما نوصل
Хочешь разрешили?
А здесь значит, скорость больше, по-моему, ну, смотри, допустим, он 30 градусов,
Хорошо, что такое velocity? Она из чего состоит? Из чего она состоит? У него два компонента. Нет. Скорость нет. Есть управление. У меня наши эмоции. Рисуйте рисунок, где нарисованы они, тогда все правильно. Нарисуйте. В общем, ваша задача нарисовать, как это выглядит в жизни, то есть куда направлено. Да, молодцы, да, правильно. Расскажи.
Yes. Okay, so first of all, it's moving in a circular direction. So we take it gives us like the S as
Yeah, I
this.
guess.
Okay, so we will get from the natural form we will get the sigma dot. We have the sigma here, so we take the derivative of it, and it will give us this equation. After that, we will calculate. And it will give us the velocity and the direction of t.
So I see, but have you drawn so what consists of velocity? What it consists of magnitude and direction. Where is velocity direction? Okay, I see.
It's down.
Where is tangent? Where is n and where is the general?
I know in general of what? Of
Complex acceleration. Draw it and you finished. You didn't draw this one.
Draw it here.
Of course,
okay.
because you
Okay.
also.
Let's understand.
You know that you're already wrong in drawing.
It's moving on the other side. It's positive.
You need to show the direction in general. Don't worry, you need to. Have you finished, guys? We have two teams who need then. Я у тебя рисунок Ага, очень понятно, со всеми вариантами. Ты понимаешь, что они уже это нарисовали. Делаете.
Я бы его вообще не делал.
И тогда ты получил бы 0, потому что в задаче написано найти скорость. А скорость она состоит из чего? Из направления и угла. Это угла.
Смотри, второй был
Ну, то есть, просто нарисовать. Тебя требовали физики всегда. У тебя вообще-то есть все скорости и ускорения, тоже нужно нарисовать. Нет. Потому что у тебя есть ускорение, у тебя есть, соответственно, тангенциальное, нормально, ты должен все нарисовать. И нарисовать красиво. Конечно. У тебя ускорение тоже содержит каждое ускорение имеет направление, и соответственно, что вектор он содержит.
Нет, просто
когда у тебя
задача найти, нарисовать.
Когда просят velocity, и, к сожалению, говорят, называется физики в том числе, что это не просто модульный текст. Я не могу рисую. У них красивый рисунок. Такой рисунок я тебе на экзамене не приму. Вы вместе работаете. Согласен, с ним верно.
Больше сказать, у нас решение.
Okay, so congratulations, we have one who solved it.
Prize will be more problems.
Minus 2 points.
We have gift.
Oh.
Thank you.
Okay. So,
أنا أتفق على الكلمين على الرجل
I will give you, how to say,
Yeah, now it's good.
Okay, so try to explain. Guys, pay attention on the whiteboard.
Okay, first I would just like, oh, natural form, it must be sigma. Just, and then I thought, okay, I can find how some, like later somehow, but I think, okay, something is wrong, like I don't understand something, then I was okay, it's just a circle. And it has constant radius, and basically we have this OM, which is residence with angle.
Yes.
And So the perspective must be something like this. So this is the law. They did this thing here, and it has constant radius. So we just what changes is the angle. So the law is for the angle, and so if I expand this and take the derivative twice, I get v and a, but I didn't because I realized it's too late.
Okay, actually, it's nice move, and I will explain it later. Who, some of you could you explain on the whiteboard how to solve? About this, let's say, you thought correctly, but in this case, I will explain how to do it. Okay. No, stay there.
Okay.
Because we have the bus already, so the function of the bus, we can calculate the b like that. So we can calculate the derivative from here, and we will get the velocity. So it will be if we substitute t by 1 and r by so it was supposed to be function.
Because of the property.
And we already have the explanation from the last lecture. So this is a explanation of tangent direction and then
Tangent. Are you explaining to the whiteboard or to the audience? Whiteboard, did you get it?
so this is the tangent acceleration and this is the normal acceleration. So we can get the second derivative from this equation. It will be 4 over 6 or minus 2. And we can take the square of the
Okay, you solved it. Okay, what about direction? How did you solve it?
Okay, this one will be minus 2. And the normal will be from here. So here will be because it's negative, so the acceleration, tangent acceleration will be in the negative
It's the reason why I
direction.
said it wrong.
In the negative direction, and will be in the normal direction.
Total acceleration.
Oh, that's it. Okay, thanks. Okay, now let's return to your thought. Actually, guys, it's about thinking. That actually, what he tried to do, we have planar case. I hope you're right with it. And we can solve in different ways. One is just to keep right. Okay, we have some. What's this? We have, how to say, natural form. We used to work. Так, Гагарка, верно? Okay. We have natural form. I used to work with other forms because I just used to do it like this. Okay, let's transform it.
And in this case, we need to understand what coordinate should be. And yes, in this case, yes, we also can use x and y actually. We can do it like this, but it will be a pain in the ass. And in this case, the best way is yes to use alpha there. Even more, we can find it will be 60 degrees there. Yes. So, and could and solve all this task using other equations, not from the tangent one, I mean from the natural form, but just to take derivative 1, derivative 2 and solve it. And it also will be okay, and you also solve this task. So, your way of thinking was correct. That you didn't solve it? Yes. Just matter of practice. So, you also deserve, because you are a brave guy.
Oh, thank you. Calories.
Can I ask a question about this way? So he was trying to transform it to another form,
yes.
and then like try to solve it in that form?
Yes.
Okay,
Because can you find in this in radius vector, can you find the accelerations and other stuff? Of
yes.
course.
Okay.
You can do forms is just forms. You can go from one to another. In this case, for some of you, it was easier to do it. Actually, there's no need to go to other forms. But for instance, for drawing, for me it will be easier to go to this form because I know theta. Actually, I didn't say you to draw it in real. It's the reason why you didn't do like this. But in his way, he can say, okay, after this you can find theta. It will be 60 degrees, and you can draw it correctly, completely correct, because none of you draw it. In
the exact
yes.
angle.
Yeah.
Do we have some rules where we direct tau?
Tau? What the property of tau?
Always
It's
tangent.
tangential.
Tangent to what?
To radius,
To trajectory.
yes.
Okay, in this case we know that it's moving in this direction.
But
We assume that we're moving in this direction.
so just assume. But
Yes, in this case.
So
Actually,
we can draw it the other way and-
what do we need to do? Okay, you're right. What do we need to do first?
We need to assume first.
First we need to say, coordinate system. In coordinate system we are saying that, okay, we have a natural form. In natural form, what do we have? Actually, we have only one, actually most of the time, from 0 to t. We don't have direction itself. We can say that we're going in the opposite direction or in this direction. So we have circle saying that, okay, you can draw like this and say that I'm moving in this direction. Okay. In this case, it will be positive. Yeah.
How can you calculate the cosine and sine?
Sine cosine there?
How to calculate the angle?
Without knowing the angle.
Without knowing angle?
Yeah, because do we have angle here?
know the way you
I'd like to remember you the school. Yes.
Your school is different from my school.
Path divided by radius. It will be the arc of the circle. Yes, it's ad hoc solution, not general, but despite it. So far so good? Okay. The second task is mine. So, first of all, when we are saying the task, what do we need to do?
What's given?
We need to think and read. So let's read. These are equal to 2, rotate around, oh, okay. I see, fine. It moves, we have some law of this motion, of how it rotates. It is needed to find angular velocity and acceleration for the body, angular acceleration. Also, you need to find the m for this. Okay, so in this case, we need to find angular omega and what? Angular acceleration. Also, for some point, we need to find velocity and okay. Okay. What I'm thinking. Okay. So I need these formulas and I can just write down it somewhere. So formula for this, formula for this. I already know what I need to have, my prerequisites, let me say. I took check sheet and understand, okay, I have this. Fine. What else? We know that M, its body. And yeah.
They can't see the. Like this side can't see the picture.
Probably you can. Let's. Okay. No. Let's rearrange table. Okay. Yes.
If you want.
And after this, in next class, we will rearrange it. Or even this line. Let's move this table to this one. I think we will fix it. I like to have a small. I hope I'm not so fast. Or fast. That's fast. Okay. Let's fix it.
Радиус у нас 2 чего? Сантиметра,
I say in Tatar. Okay, we fixed it there. Now we need to fix the also camera. And the second camera, yes. This camera is just to overview of the room. What's happened there? Okay, nothing happened.
Кстати, вы можете экраном в другую сторону поставить камеру, чтобы удобнее было.
Фронталку снимать
По сенсору войти и представить камеру в другую сторону.
Okay, for now we will do it another way. Okay, so let's return. By the way, does anybody have micro USB or power bank with micro USB?
في شاشة؟
لا في الأوضة بتاع السماعة.
لا يا شاشة مش مايك.
So we have 17% of my. Okay, guys. Fine. Okay. What else? We know that. Okay, when we are talking about velocity, where we can put a velocity vector, will be different. For instance, velocity vector there or there or there.
Should be tangent and should be on the particle.
I mean, we have our wood rotates. Do you agree? Agree. Point of rotation.
No, it doesn't matter.
This will this VA will be equal to this VB. Is it equal?
No,
Well,
because
no,
that
no,
VB it
It's
at least
inside.
rotates in another side.
Yeah.
Okay. Okay. Fine. You are thinking nice about this.
No, it's different
No,
radiuses.
How can we
different direction.
We should draw radius to this radius vector to this point and
Yeah.
Draw tangential line.
How can we understand that it's with, yes, you're right, it's not correct? I mean, they're not equal. At least what do you think? How can we prove it using equations?
If I'm not mistaken,
Asking.
okay.
Как ты можешь понять, что вот эти скорости разные? Знаешь? А почему? А что связывает радиус? Откуда он появился? Ну, радиус отлично. Почему радиус? Okay, she said radius because we have, but where we can find radius in this case?
Yeah.
An equation that connects angular velocity and linear velocity. Okay. Why you rank like this but not in school? Because in general it's in general. And of course we have cosine 90 and or sine 90 and it will be equal to 1. Okay. But other question. Omega A and omega B, is it equal?
No.
Yes.
So, raise your hand if you think that it's not equal.
like radius to those points is equal, then yes.
Is it the same radius?
Like if distance from
So, is it equal now?
Yes.
Why?
No one has raised their hand, so.
How is this vector called? Is it vector or maybe something else? Well, it is.
Quasi-vector?
Yes, exactly.
So it doesn't matter where it is located.
It's the main reason because in this case, when we are talking about this VB, we can be theirs. This and in this case we can use cross product. So is the reason why when we rotate something, omega will be equal in each.
And it points towards us, yeah?
Yes. Actually, use 500 rule like this and see. There are many possible ways. Okay.
What operations can you do with quasi-vector?
All the quasi-vector just first two properties of it. First of all, it's not real vector. I mean, real vector velocity. It's real. We know how to where to apply it and the direction of it. In this case, we know only direction, and we can apply it in every place in your body first. So it's not physical. You cannot feel it somehow. I mean, actually, when we are rotating, we feel a linear velocity, but not angular velocity. Let me say like this. Because we put it in this direction, when I'm rotating, I don't feel that I'm, I don't know, flying car. Try to think it just on fingers. And second way that you put it everywhere in every place.
How to show that it points inside the board? Like
so in the physics
X.
you do it like this.
X or
X. It's arrow. Okay, but you can spend time and draw and say like this, I don't know, but of course I'm joking. So to sum up, we know that we know some equation for these guys. How can we solve it? Just take a derivative. We already have C from time. C is just angular stuff, so it's phi dot, phi 2 dot. Hooray! We did it. I am too lazy to do it by myself, so we have C and so in this, what it help us to understand? Sorry for messy, but we don't have anything plain whiteboard for it. We can understand how it moves. So actually, it's already the picture from the book which provide us. But in this case, we understand that it moves in opposite direction because we have velocity in one direction, but acceleration in other direction. So we decelerating our object. So it rotates, for instance, like drawing there in clockwise, and we decelerate. Okay.
But why minus 8?
What again?
Is it minus 8 or
minus
equal?
It's equal.
It's equal, okay.
Okay. After this, we know for a tau and a normal, also equations related to this, it will be NVO. And we also calculate it. No problems. How to find velocity for this guy? As we discussed, we know the connection. What else? What do we need to know? Of course, we can put T and find everything. In this case, as I told you, we're thinking in an algorithm way. That we just, in this case, when I read this task, I understand that mainly I just need equations. That I need some formulas how to find it, because we don't need to operate somehow. I just read it. On next task, you understand that you need to think in another manner. So, and velocity acceleration, find. Hooray, we did it. Of course, we complete total. Most of the time, on planar case, it will be just Pythagoras theorem. In spherical case, not always. So that's it. Do you have any questions? Because actually I just showed that this task is about how to use equations from cheat sheet. And also how to go from one, let's say, when we're working with the angular velocity and go to linear velocity. Because in this case, it was easier to us to find everything for angular stuff because we just need to take derivative. And after this, I finding linear. Can I do it in a different way? Of course. I can try to find velocity, or I just go to velocity, or even, how to say, find, we have theta, we can go to linear somehow, to x, y, and after this, go solve the stuff because it's sine cosine, and try to solve it this way. Of course you can do it. If you see it only this way, do it like this. You understand that, as I said, no right solution. We go from natural stuff, I mean like this, go to the xy, solve the task, great. Actually we can say that this one also looks like, I mean, not Cartesian space, but angle не афинный, полярный, yes, polar coordinates. The next task is also mine. Okay, we will return to this stuff. After this, we will have a nice video. Okay, so now it's time to be a translator. So what do we have there? We have one wheel. I want to use Google.
But it's not showing it, but it's okay.
Not far?
No, it's too far.
It's not really.
So we have one wheel, another wheel, third wheel, but it's connected to each other. Then we have a linear crank. I mean linear. All they're connected by gear, and this also gear. Actually, have you worked with gears on physics? So I hope you remember that it's also shown as a circle, but you convert as gears. Because if we are not talking about evolvents, you will cover it in the next semester. Evolvents is a profile of the gear. And in this case, you can just assume that it's wheel. Okay, what do you know about this point and this point?
Tangent.
And what else? What about velocities, linear velocity of this? Yes, why?
At which point?
On connection between two.
Because they connect.
What? Because?
They are connected.
And what else? What
If
once
velocity will differ, they will
slip.
Slide.
Yes, so we need to assume that there are no slip lines. Actually, there is. Probably it should be there somewhere. But okay. Now, so we can. It's acceptable only when we don't have slip line. But in future we will solve task which show us right. By the way, next class I also show you the, let's say, our final tasks which will be on exam and so on. Why? Because I know that you used to think that we are learning physics for something, but you didn't get why you need it really. And I will show you practical cases when it will be applicable in robotics. I have such slides and I will show it to you. So let's return to this. Okay, so okay, I don't want to draw it. So we know all radiuses. So most of the time you have all of the dimensions. You don't need to find it usually. So time one, you need to find so it moves, and you need to find the acceleration and velocity for this bar. And you need to find when it accelerates and decelerates. And we know, so it's a, how to say, actuator. We know the law how it moves. It's this.
let's start to solve this task. So we need to know.
Can I ask one question? So this moves constantly. That means this rod is like.
It moves not
we
constantly.
assume
it's not constantly.
No, I mean like this is the law, right?
Yes.
So I mean like it moves in one direction at least. It doesn't rotate to another direction, right?
Actually, it's dependent on the law. C for t minus t squared. If t equal to 0, in this case it moves in one direction. Not one. It will be 0. Second is
Be always positive.
positive. Yes, in this case.
So it's always rotating. So this means this rod like doesn't have an end. We should assume, right? Or
Doesn't have what?
like length, like a specific length.
Probably. No, we have what again? We have hyperbola. Hyperbola have two dimensions.
No, I mean I'm talking about the rod. So this rod moves up and down. I mean it's like moves in one direction.
Yes, we are assuming that.
Okay.
Okay, we have this happen. What we can do with it? We can find the accelerations and also stuff. So V1 we know. We know also omega 1 is that one, and we know fine. Actually, we calculated it. You can see that omega will be 2 and acceleration will be minus 2. So we started to accelerate. After this, okay, we find everything for this guy. We need to go to other stuff. How can we do it? I asked you and you answered that because we know about linear velocity. So Vk, this one, is equal to omega radius 1 equal to omega 2 radius 2. We know this guy, we found it. So in this case we can find omega 2. If you need that I need to expand all bracket and so you can say it directly. In this case my goal to help you to intuition and understand how to think, not how to solve by your hand. I hope you can do it. Okay, we found omega. What can we do with the second?
That's the same one.
What can we do?
Well, the omega for the big wheel and the small wheel should be same, right? Because
Yes.
it's angular. So
This one, yes, but also can we find something acceleration probably or something like this, or maybe angle? Do we need angle? What do you think? Can we find acceleration? And how? Look at this guy and this guy. How's it like? No, I mean not about number, but I mean forget about this. I mean about this and this. How can we find angular acceleration for the second wheel? So to sum up, yes, you can. You just need to again take a second derivative. I mean, first derivative for this guy. Bam. We find all acceleration. We need to find, how to say, acceleration velocity for this guy, for bar. But for doing this, we need to know all accelerations and velocities of other components, because otherwise we cannot do it. So we found omega 2 and FC, something like this too. After this, okay, fine. We need to find VL. We finally go to this one. How can we do it?
You know, the omega and the
Well, spread by R.
R2, small. As you said, because they are fixed, the smaller bits are fixed, we just need, yes, the same omega
but the other radius, yes.
Maybe it's something I don't understand, but shouldn't be omega 1 be 2t, not 2?
They are assuming t was 1,
T,
I guess.
is equal to 1.
1 second.
Okay.
Yeah, you're right that if we are not solving in general,
Okay,
it
okay.
is. Okay. We found VT. Hooray. Also, A. How can we find it? Take a derivative. So, the final boss is tangent and normal.
We can
How
check them.
it's a bit tricky in this case. How can we solve it?
Which one is it?
Yeah, exactly. It's the reason why we took, we found epsilon for other stuff. Nice. Because from this part we cannot do anything. But we know that it's also have some linear, so this velocity connected, and we can find this acceleration. And yes, it will be. And in the end, we just. So, can you explain the algorithm from the beginning?
Okay,
So what we did in the end, why we did it, and so on.
Okay, so we already have formula for V for the first circle. So we find the angular velocity and angular acceleration for the first wheel by taking the adjusted derivative.
Okay.
Then we know that at point K, linear velocity must be equal. So we know we can build an equation between two angular velocities for the first wheel and for the second wheel.
Between two angular velocities or linear velocities?
Linear velocities at point K are equal, then
Yes.
by knowing radiuses we
Yeah, correct.
yeah. Then because we know that radiuses are constant, we know that angular velocities will change also the the same. So we can find an equation for angular velocity and angular acceleration for the second wheel, and we know that at point A, second and third wheel are connected. So we can find velocity at this point by assuming that angular velocity here is the same, so just multiply. And at the end we should find accelerations at point A, and we can apply angular velocity and angular acceleration for the second wheel.
Okay, thanks. Who didn't understand? It's okay, we can try to solve it again, no problem. Alice, did you get? Okay, I will ask you later.
Can we find last tangential or acceleration and normal acceleration by using dot product and magnitude of velocity?
What do you mean? I didn't get.
Can we use not angular acceleration and angular velocity, but the product and magnitude of velocity?
You may try. Actually, the easiest.
Acceleration itself.
Yes. If you know acceleration itself, yes, you can. So, the video is about that, guys. You in robotics used to work with engineers. Even more, maybe you will work with a manufacturer. Who work in manufacturer. As you know, these workers are not very, smart probably. And when you talk, you need to be on the same level with them. So you need to understand them. And
be one of them. So now some of you will learn how to squat like a true Slav.
Welcome friends, I am Boris and today I will be showing you how to squat like true Slav. Let's go. Yes, Boris! Many people they ask me, Boris, show me the way of the Slav. Teach me to squat like you do. And of course, I'm happy to help. But consider this, my friends. The Slav squat is not just about squatting down. No, it is about technique. About showing your Slav levels. And most of all, being comfortable wherever you are. If it is on boat, at home playing CSGO, just hanging out with your Courtney friends. It is always good time for squat. So many people I see trying to do Slav squat, and they do it all wrong. You see this? Correct squatting. But this shit is all wrong. This is what we call the Western spy squat. You see, no balance whatsoever. As unstable as a stack of thousands of beans. But this way, very stable. You can squat for 10 hours if you want. Heels flat with ground. This way you have best comfortable resting position and you are always ready to get back into action if the situation requires. Squatting on toes, it removes your balance and it put extra tension on thighs and calves. So remember, heels touch ground when Slav squat around. Here we have good quality example of squat session taking place in front of bar on Monday morning. How do we know it's Monday morning? Because sign says we are open and all the Slavs look very refreshed like they are ready for work. But work will wait, because beer needs attention. The point of this image is that one of these Slavs is Western spy looking at you, Koya. The legends say that only true Slavs are granted the gift of squatting down on full heels. Here we have very nice quality squat from fan. Thank you, Razvan, for proving your Slavness. Have a Kotnik award. Bartek, Eugen, and this random guy. Good try, but you need still more practice. Rafal, good squat. Mr. Gold Zeta watching Copy FM doing perfect squat. This Gopnik, this guy on Moon, this cat, and this guy from Eastern European Men's School. Good squats for everyone. If you are still having trouble doing the Slav squat by now, well shit, I have bad news for you. But not worry, Boris not give up until last try. Objective of Slav squat is not put toes first, but put all pressure on heels. You see, this way you leave hands empty for drinking vodka or peeling potato if you need. A perfectly balanced Slav is a happy Slav. Now you should be able to squat like Slav anytime, any place. Well, thank you for watching, my friends. I hope you enjoyed this first video of the series of how to be more Slav. I will see you next time, friends. Stay cheeky-peeky.
So guys, now it was our first step to be prepared to be a real robotics. Okay, so now we are going to dive deeper. Actually, is the reason why I have to change today's class because of this guy, second approach. You will learn it in the lecture, and it's the reason why we are not talking about this. Actually, today we are covering mostly only analytical and geometrical way. By the way, forget it for now. Not forgetting, rest. It will be our task, and even more it looks like your home task. So, what the task is? You should find, you need firstly simulate the mechanism, so obtain all positions for all points. So, we have point A, C, and B. What does it mean? It means that you need to find the kinematics for it. So, x respect to t, y respect to t, where the A, B, C. Yes. Also, you need to find velocities. Velocities means not only the magnitude, but also direction. Accelerations. And draw close to previous statement. Or show it on simulation. How to do it? And you have all positions. How to solve it I will show later, but simulate. As I told you, your home task will consist of coding. And okay, right now I'm asking, how to simulate, what do you think? What will you use as a tool?
Wolfram.
Wolfram, do you think you can simulate it? How? You will. Okay, Wolfram, what else? Python. Okay, what else?
I don't exactly understand what do you mean simulate. Just compute the coordinates, draw it, or what?
Yeah, it's simulation. What does it mean simulation in real life?
To actually, execute it step by step and make sure that nothing is conflicting anything.
First of all, simulation is it shows us what happened and it should correct in terms of physics. So you are solving equations, put it, and for each time you draw this. It's simulation. Am I right? Actually, we could. What do you think about chi analysis and so on? How it works? Game physics. It's all the same. It has a lot of equations, nonlinear equations, numerical. You solve it numerically, and hooray, you can play games. Actually, you're doing the same, but for this guy. How it looks like? First of all, blah 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 blah. I will show you how students from the previous year did it. Actually, it was from linear algebra course. We found a very nice tool called GeoGebra. Probably some of you have heard about it. And it's really nice because you can do like, first of all, it's your home task. You need to understand, and you may see nice equations. Is the reason why you need to code. But in the end, you will receive this result. So it moves. All velocities change according to their magnitude and dimensions. All rotates, and this guy also moves. So expecting from you this result. You can do it in GeoGebra, in Python, as you like. But you need to show if it's mean the simulation. Of course, you can do just plots. But first of all, it's not very interesting for you, as for me. And it's not very intuitive, too. When you do this simulation, you can easily make plots. Because yes, you had the first as a plot, but simulation is meant like this. Also, you can use other, let's see, application like linkage. It's not very nice, but it also might be helpful. I don't know how to draw the velocities and put equations, but you can simulate some mechanisms to check. At least you can, let's say, put it there and understand how it works. So sometimes you took the mechanism, but you don't want you're not understanding how it should work. You can draw it there and put it and pray. So this task. What the when we are talking this task, we are talking about mainly kinematics. If we solve kinematics, we can solve everything else. What approaches do you know? How did you solve it during the physics? Probably did you have such tasks like this?
Like simulations?
We had
no simulations, of course. I know that no.
We have one task on simulation.
What kind?
Like from Olympiad on the topic of like rotations, basically, and I completed the task on Wolfram. So you have короче, типа шайба и ворота. И она, то есть, если она вертикально расположена, на ворота может не попасть. Нужно, у нее скорость есть определенная, то есть она может при вращении что-то попасть.
Я понял, комплексное решение. Я понял, у нас будет в конце такие задачи. Okay, so, about kinematics. Do we have forward kinematics and reverse kinematics? I hope you know. What the forward kinematics is?
You provide angles and you get all the coordinates.
Angles?
Unknown variables.
Parameters,
yes.
It has no fancy name, but okay, let's stop on this.
So as a student, you know the movements they make, and you need to get the positions. And the inverse is the opposite. You know the positions they want, but you need to find the movements.
Okay, so in this question is for this guy. What will be easier, forward or inverse?
Inverse.
Okay.
Forward. Easier to do?
To do.
Yeah, forward, of course.
Forward? At least, what do you think?
I think inverse.
Why?
Is it to do what?
No,
to solve it! I want to control it, to kill humans and exterminate, like...
It would be easier for forward, but like for a user to use it, inverse kinematics would be.
And guys, what do you think about this one?
So you have two stuff.
It's just this like a parallel platform.
Yes, and you can apply some kind of optimization to find the shortest way of movement.
So for this guy, forward will be easier. Why? Do you remember that coordinate transformation we did it today during the?
Yes.
You're going from this to this point, from this point to this point. Hooray! I solved for kinematics. For kinematics, I need to solve my soul to the evil. In this case, the opposite way. You cannot solve it using. Actually, you can solve, and we will do it. But much easier to use different ways, and inverse kinematics will be easier. It calls closed loop system and it's open loop system. And parallel robots works like this, and it's chain robots.
Like if you want to control this manipulator.
Yeah.
Like won't it be easier to just give as input like coordinates that we need to reach by end effector, and then by inverse kinematics like define angles which we need to rotate to get into position.
You can control like this, yes, of course. You control a robot using inverse kinematics.
So it will be easier to control with inverse kinematics.
I asked how to solve. What will be easier to solve, not to control?
Equations for
like for you doing the equations forward will be
Actually, you
easier,
have
but
Introduction to Robotics, and they will explain it later. But in robotics, in Introduction to Robotics, they will give you more, how to say, precise robot solve. In this case, I told you that this course is more about methodology, how to think, not how to. And when I talk about kinematics, there are three approaches. The most, so I put it, you can read at home, but it's very crucial to understand. Because to be honest, when I was a master student and we have introduction to robotics course like you, almost like, I had the problem that do you know R robot with humanoid in the down, and I need to find, I need to make the control arm. So not only control, to do a lot of stuff. So so my 6-DOF system was raised and his arm in the end, without fingers. So I cannot find kinematics for 3 months, and everybody laughed at me because when I solved it in vector-based approach, MATLAB told me goodbye, I cannot solve it. When I tried to use triangular approach, MATLAB also said me goodbye because they're almost the same. Because when you have a quite big system, the problem appeared that it's non-linear system, and you have a lot of signs. I mean, positive and negative signs. And as a solver, you need to help solver understand when it should be positive, when it should be negative. I just try to. Of course, without practice, you cannot understand it right now. But when you try just to take into account. So, but one of my major colleagues explained in a geometrical way. When you think not in terms of vectors, but in terms of figures. For instance, when we are talking about falling bar, we will solve it in the next class. It's easier to explain. It can rotate like this. Okay, for you it will be easier like this. For understanding. We have one. It's just to how to say. It's a 1-DOF system. Let's try to find kinematics. We know this, great. We know velocities, thetas, accelerations, whatever. Can we find this one? Yes, because theta multiplied by radius. Hooray, we found this point. Okay. We have B and C. We know C. How to find B? How you will do it?
Like we know the velocity and angular velocity of C.
Of B. B, we need to find position of B. I want to simulate it. How to find it?
Well, if it's rigid, then we just like distance and direction move it. No.
Again,
if A and B are connected by a rod, that
yes.
doesn't put the problem.
So no, they can, let's say, like this. So
they can change the angle.
So A and B moves also.
Yes, of course. Everything it moves like this, so it can be.
Distance can be changed.
Of course. Between A and B,
No.
this change? No.
No.
It won't change. I can think that B is intersection of two circles. One circle and another circle. I know equations of two circles. I know C. I know this. Two equations, two variables. That's it. And I put it on nonlinear solver as I wrote it there. And hooray, I solved this task. And you will have much more complicated, and Yarek and other guys from previous batch, they just saw one task. They have about A equations like this, circle, 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 circles, and they solve the task. They just put it on MATLAB, and hooray, they solve it. In vector form, yes, start to write cosine, sine, blah. It will be in the same. In the end, it will be the same. But in terms of thinking, it's much easier when you can imagine what is it. For instance, let's think about this task. So I will explain. It's called in English. It's slider.
Yeah.
Slider. Кривошипно-ползунный механизм in Russian, crank, blah blah, I forgot for it. I will refresh how it's called. Crank something sharp. Okay, so it rotates like this, it moves. You saw actually the video how it looks like. What can we say about it? Of course we can find A, agree? What about this one? How can we solve it? Yes, it is solved in vector form, but in terms of
In geometric?
yes.
So it can be just.
Okay, probably can apply the same thing.
Is it circle? Can you find circle there?
Yeah, there's for example a circle in the middle of O and circle in the
AB
middle of
and OA you already know.
B. OA and BA.
Okay, in this case I found A, but I couldn't find because I don't know B. B is
moving, yeah.
Circle, line.
It's intersection between line
And the circle.
and circle, yes. Because it moves like this and this one.
Sorry, what again? What was it?
It's an intersection between this rotates in a circle, but this slides. So when this moves like to closer, this completes the circle. So you can imagine it like as a circle intersecting with a line.
Yeah.
Okay, let's try to solve this task in all manners. I mean, in three manners. Actually, again, this task should be better for you when after the lecture. Of course, I know that most of you won't understand anything from lecture, but at least when you see 2 times, it's better than see from 1 time. But in our case, we don't have such choice. Okay. Again, so we have such mechanism. Actually, the method which we didn't cover today, instantaneous velocity, it's older method, and not older. Actually, those methods can help you easily solve the task in this precise position, but not in general. You cannot simulate anything using this method, but you can solve in 2 steps. In this case, you can simulate, but you need a computer, because to calculate R cosine, R sine, it's quite tough. At least not now. We are not in calculus, so this it's not our problem right now. Yes, we are too, let's say, adult for this. Do we have something better?
Okay. So again, our mechanism contains one DOF, degrees of freedom. Do you know what is the degrees of freedom? Who can explain in layman terms?
No.
Okay. We do. Can you explain no? What others?
In which dimensions it can move? In which directions?
How many?
Free variable in function that describes movement.
Oh, this math guys.
It's basically like one motion that the object can do. Like it can be a circle. It doesn't have to be like one direction. It can be like one type of motion, not mixed type of motions.
Okay, let's drop all this fancy stuff. Again, this guy can move only in one possible direction. What about manipulator? You probably understand that it can have many directions. What about this one? Okay, I thought that was better.
So, is this part is connected or not?
All of them connect?
No, I mean like at the ground level.
Ground, yes, it's connected. I mean ground is ground. What ground?
To
DOF, yes. Why? Because
it can move like up and down, left and right. Like
it can move, yes. We cannot, how to say, understand what's going on in one point. It can be different positions and without changing. So, for instance, it can be in this case and in this case. It will have completely the same kinematics. Bam bam, just like this.
We just discussed like the degree of freedom is like one variable. You said it's 2 DOF, but I mean we don't have 2 dependent variables here.
Okay, let's forget about right now. Most of our tasks, probably except last 2 weeks, will be one DOF.
Okay.
For now, let's. Lecturer should explain it better because right now we don't have time for this. Just in my understanding, yes, when you see manipulator and can move, variables, yes, it's correct understanding, but you need to feel it. When you see the robot, you need to understand how many degrees of freedom does it have, and the different. Yeah, you have difference between mechanism itself and and each part of this body. Okay. In the other case, we have at max 3 degrees of freedom. Because planar case move x direction, y direction, and rotate theta. That's it. Okay. So in this case, we know that velocity is constant. So in this case, velocity is constant. So we can find that t. In this case, x of theta will be x at t. X, capital X, it contains X and Y. I mean, it contains all coordinates, yes. So, it's okay. We just integrate and find below. As I told you, there are 3 possible ways. Now we are solving using geometrical way. Point A can be found how? Or A cosine theta or A sine theta. As we discussed, because just
Those not headers, feet.
Yes, we found it. Like this. Point B and C might be difficult, but we can represent point B as intersection between line and circle, yeah. As we discussed, that line and circle. X back minus x a square plus yb minus a square b square. In theoretical mechanics, there are common notation looks like this. If you know something magnitude or direction, you make one highlight. Underscore. In this case, what do we know? XA we know?
Can you repeat what is the last system about?
What is it?
Yeah.
Circle. Equation of circle.
Ah.
X, B. We are talking about round B axis.
Got it.
Minus XA. Yes. YB minus YA, AB. Then we know XB. No, we don't know. We want to find it.
Can we choose the reference frame on point B? So this will be point 0. And the
XB moves. XB moves.
But we can change reference frame to B.
And
the other system will be
same
moving.
result.
The same result.
Going to be everything else moves.
Everything else moves, yes.
Yeah. will be not easy, yes?
Think as comfortable.
As for me, it's more intuitive to think, and okay, I'm going just from left to right. I mean, from what is okay. XA we know. Y, B. Do we know? Do we know this?
Yeah, because it's one there.
It doesn't move.
Then no.
We know this. B we also know. The second equation, because it moves only along this way, we can write that yb equal to 0. So how many equations do we have? 2. How many variables do we need to find? 2. For A we found xb, yb. So right now what we did, we know this position, this position, this position. We will also need to find on the C. Of course, in cheat sheet you saw that I have a solution. There is how to it consists of the calculations, calculations. And how to find XC? How to find this guy?
For example, we want to AB part, so if you know coordinates of A and B, you can find coordinates of point C.
Intersection of if you take two circles and one on A, one on B.
Yeah.
So it will be intersection.
You convert two equations into circles.
Это главное зачем? You know, it's capital. So, what do you think?
Не, ну как контекст.
Vector.
Нет.
Is it BC multiplied by BA?
Yes, but there is vector. Do you remember this? What is it? Projection. Actually, because we know we have BC, we want to find, let's say, we know XB, we already know it. In this case, we know BA, we know the magnitude of BA, and the vector of it, because we know these two guys. Actually, what is it? Again, I told you, think in terms of vectors, bases, and so on. I'm in this position. I agree? I need to go to this point. I took this coordinate. I found this vector. So, it's B. We are moving, so this vector help us to know the direction where we need to move. The A provides us to make a unitary vector type. This one is
unit vector.
Normalization.
Yes, unit vector, yes. BC, it's the way where we need to move. So, in this way. Everything else we know, so we need to find BC. We know AC, just AB minus BC, we know it. So, we know everything. Okay, I see you didn't get what's going on there. Let's spend more time on it. When do we need to finish? 12,
20 minutes.
10 minutes, yes? 20, okay, fine. So, today's more like lecture because you don't have material. It's the reason why I make a circus in front of you. Okay. Probably it's better to open
Projection.
Actually, yes, it's just project. But
Projection of BC on this right. Right. Do I not understand correctly? That is projection of BC on the AB.
Let's open in your other course. I have my own slides, so it shouldn't be a big problem. Okay. Because I just like to say that so everybody understood, you understood, and after this I go. So. Two lines. Blah blah. Okay, let's try from this. The topic is into the matrix determinant.
Sure.
When the plane. Plane and space. Where it is? And plane. Where should be the projection? Do you remember? Where did you do?
We had a very different course, but projection should be like in explaining cross products or.
Probably yes. Inverse matrixing the basis. Matrix rank. Nah.
Probably changing the basis. Not now.
So let's use this one.
Before listed squares.
Determinant is also it's area. Never mind.
It's my understanding of my English. Okay, guys, I will prepare it for the next. So we have two questions right now. First, this question I will explain it better. And second question was about
the one.
Who understood why in homogeneous matrix we have 0, 0, 1 there? It can be different.
Because that coordinate does not change.
What do you mean?
Your coordinate is the same, like z equals to
It's the same.
When we do a transition matrix.
I mean in homogeneous matrix when we combine
rotation.
Okay, in planar case, okay, what about I got why you okay. So in 3D it matrix 4 by 4. Yes. So there is no z axis at all. I mean it's there inside. Rotation matrix and transport matrix. Translation. Who knows why it looks like this? It can be different.
Because we cannot affect
actually can be if one of them accept on scalar, second one accept on bending. Actually, in robotics, you don't need this guy. It's always will be 0, but in some physics, it can be different. Why? You can even just accept it, or I will try to explain it to you on next week. Actually, I don't really remember. I know why, so I know where to find the information about it, but right now I forgot about it. Because actually, in robotics, you just need to accept that it's a trick.
Like,
Yes.
like, so we have this homogeneous matrix, which is 3 by 3. We have vectors who are 2 by 1. So what we do, we would like how we
So this 3 by 1, you put it by 0, but I don't know. Like
originally, you have 2 by 2 plus 2 by 1.
Yeah, okay.
You
yes.
use magic, you increase dimension,
Yeah, yeah.
and put it.
Yeah, I understand. It's a way to write it, but we get this H matrix. We don't do anything with it. We just look at it and extract parts of it, or what?
No. Actually, you can. In forward when do you have forward or international robotics?
Next semester.
Next
Next
half?
block.
Right now, so they will explain it. It's there.
Okay.
It's there. I'll say.
Okay.
So like if we have two-dimensional coordinates, we add another dimension? Like
Yes.
separate.
But that dimension is not considered as the Z dimension.
No, of course not.
That's
Z.
why.
It's not
Okay.
Z. It just
So it can be
it's
one.
just trick. Yes, it just yes.
Okay.
Just accept the free. You write 0, 0, 1 the end. Why? Because if you put all zeros and you try to calculate it, you will receive all zeros in the end. Because or you can yeah. Okay.
وانا ما تجيب عملت نفس البتاع ممكن نستنى نفس الوقت كنت ترد عليه كده
معناها مش عملت نفس الغلطة. بعد ما كنت كده صح. بعد ما كنت كده صح.
ايوه انا كنت محتاجه
About vector form, we found OA. I think you agreed with it. I mean, the way. How to find the other stuff? We can write that OB. What's it? OA plus AB. Put it onto the basis. OB, OA cosine theta plus AB cosine something. We need to find this angle using cosine rule. And I mean it's for x, and for y it will be sine blah blah.
Why do we need OB? It's like a requirement.
OB help us to find B. So in vector form, in geometrical form, we just thought that we need to find this
so
coordinate.
this is
Yes,
solving
it's
the
another
whole,
way to solve this task.
the
We
whole
don't need
task,
it
okay.
because now, in our case, we know already all coordinates and we can just simulate it. After this, how can we find velocities and accelerations from the task? Take the derivative for each point. How to find directions? More interesting story. And probably it's time to explain how to do it. Okay, for the first home task in this case, let's assume that you need to find only magnitudes without directions, because it should be on lecture and we should have practice.
So this is home task.
No. Okay. Now I'll explain the home task. It was my task, and you can read how to solve it on
GeoGebra.
Yes, on my handwritings. The home task. So task should be not only solved but also coded, as I mentioned. Of course, it's written because coding is in the upper part. In some cases, you don't need to do it, but it will be only about 2 tasks, not to speak.
we have each week home task and we have 2 research tasks. 2 research tasks cost about 20% or something like this. So we have 2 research home tasks, one for kinematics, one for dynamics. And we have each week home task. So to sum up, you have a small amount of points there, but it gives you a really a high boost for your future and for anything else. And I will check it as soon as possible. I will help you to give you some mistakes and so on. Actually, I don't even need to say you anything, because when you make a simulation, you can see that you're right or you're not right. You can check by yourself. So it's the reason why I check report, I saw that everything is okay, and most of the time I cannot find anything, because if you did it correctly, you can see the simulation by yourself. You can understand that you're right.
So we can choose any language.
I wrote that not any.
Python, MATLAB, and C++.
Yes, because I don't know anything else. I know Java actually, but thanks no.
Python is allowed.
I'm coding on Python mainly right now.
Oh, Python.
Okay. Actually, for math stuff I'm using MATLAB. It's just my own decision. Because I like how it works with vectors. I know a lot of people say that MATLAB starts from 1, not from 0, and it's bullshit and blah blah blah. But let's not make this polyvar today. Yes, so you can submit it in 1 week later, but it's not recommended. Why? Because each week you have a home task. In this case, you have more home tasks, and you don't have penalty itself for late submission, but it's late submission. I mean, it's penalty by yourself, for yourself, because it sounds useless.
То есть можно в конце курса все домашки.
And I will open the ringtone. Здравствуй, небо, облака. Okay, so each home task is a report. It consists of solution. Don't forget about formal criteria. Answer we highlighted right now, and you will have other criteria. Info about tools which you are using, because for me, some people provide me in online markdown. In online markdown, it was nice because it was interesting. Some of you gave me in LaTeX, some of them just PDFs and so on. It's up to you. Solution can be a photo of the paper sheet plus close on computer. So if you don't want to, I don't know, you solve it and you don't want to put anything in LaTeX, if you want to make a good job, it's better to do it like this, because it helps you to probably find mistakes and so on. But if you don't want, but you need to write, because your handwriting, it will be 0. I didn't get even a half of it. Okay, we have 3 home tasks. First home task, this one. Actually, it looks like previous class. So you have in which form?
Parametric.
What?
Parametric.
In parametrical form, yeah. I mean, and after this, so yes, we need to have trajectory, velocity, accelerations, create an oscillating circle for this time plot, and make a time plot and how it moves.
Oh, so we don't need row, we need K.
Yes,
not
we need
radiation
K,
coefficient.
yes. Actually, it's more useful for you. Actually, it's 1 divided by, but it's easier to use K, yes. Second one is this one. I draw it in compass. Yes, you need to simulate the mechanism, velocities. I say velocities and this right now only, but if you find information, something like this is better for you. Draw plots with some material. And the last one, actually it looks almost the same as it was of the class, but you may see that it had angles. So you need to change something. And the last one, you have 2 sliders. Simulate again the same.
They're connected, right? So
yes.
Okay.
A big one.
Probably yes.
Is it allowed to simulate using Fusion?
Using
you
CAD
need,
system.
No, you need to simulate using formulas.
No, I mean like I can do
You
the
can-
plots in Python, but I mean the simulation for the mechanism itself.
For you, yes. Yes, you can. How can I check your equations?
No, I mean like I would
I
solve
don't
the
know, you
problem
make
and
it-
do it
no,
in
no.
Python, but
Simulation helps both of us understand that you solve it correctly. You can make firstly simulation in Fusion for yourself to understand that yes, I understood it correctly, it works like exactly like this as I expected. After this, you put it in, I mean you make simulation in whatever you like and see, okay, in Fusion it works the same, and the same for A, I am nice guy, A grade from the, in my pocket, yes. Just in CAD, no, because this case you cannot put formulas in it. You can just connect it and that's it. You will do it in the next semester, don't worry. Because in the next semester you have a lot of stability for it. Yes. The same, that's it. Probably I add one task, it won't be in, how to say. The problem is that you didn't solve task on such problem. So I put a task for this. It will be not coding, it's writing task. I already have it, but for 8 minutes, not a nice idea to solve right now. Just to practice in it. Case.
you mean solve it now or in the homework?
At home, I mean.
Okay.
Till the last home task. So it's 1 week, so you need to send it to me on Thursday, next Thursday. So you have 1 whole week. But this task which I put the last one, it's better to solve you till Wednesday, Monday, Tuesday. So Tuesday, why? Because you will have quiz on it. It was just preparation for quiz, nothing special. What else? Any feedback from the class? Maybe you dislike something, you like something. Maybe this video for you is holy crap and you don't want to look at it again.
Maybe like
it was a refresh. It was.
Yeah,
I would say.
disconnected us from the
Yeah.
Refresh, but you cannot solve. At least on the first day you failed.
No,
like
he
we
was talking
get
about
lost
the video.
after a half of lecture, usually overlap, and this refreshed us, I guess.
The video.
He means the video was good.
The video was good, like it made us
The idea.
refresh, like the.
Yeah, I just want to debate to have that, because we had lecture and then half of lecture, and like it was.
About break, I explain why I don't like breaks. The problem is that when we talk about breaks and the stuff, when you talk a 5-minute break, is it 5-minute break?
Yeah,
no. 5 minutes later people come. After this you need to return this. In this case, I make some competitions, make videos, it was all break like. So, sweeties you received and so on, it helps to, how to say, to refresh you. Motivate and refresh you, yeah.
One like request for the quiz tasks. Can it be like more explained, because I felt a bit confused from the first task. Like I didn't know what I want to do, like what was required. The second task was okay.
Okay. About phase.
Can you also like provide like well-structured solution after the class meeting?
Well-structured solution is there. Did you open it?
You can click on the QR code.
Yes, of course. You can click on QR code.
But it's only for one task.
For all my tasks, you will have this one.
Okay.
Today, for future, when we have all my tasks has such explanation. Your task, no, but I say you can find solvers, books, and you can read the solution from it. Yes.
About reading material, there is also the books after what you have shown us previously, if you lost Chesky, Lagrange.
Yes.
Should we read it or not?
We'll forget about it right now because Lagrange is the last topic of this course.
Also, can you like